So in the last class, where did we stop? Stopped at constructors, right? We did constructors in the last class.
Yeah.
Today we will start with getters and setters before we go into inheritance. So I think we should create a new file outside of the OOP. So if you want to create a new file outside of this OOP folder, just click anywhere in your left pane. In this pane, just click anywhere. Make sure you click anywhere so you're outside. Then you can now create a new file. Let's name it getters underscore and setters. What's that? It's a long name. Oh, I think it should be inside the OOP. You can drag and drop it in the OOP. Sorry. Drag and drop it in the OOP. Sorry about that. Have you done that?
Yeah, I'm doing that currently. Yeah.
So getters and setters, as the name implies, it's intuitive enough, is to get the fields. You know, I mentioned in the last class, the fields are like the properties of a class. So it's to get the fields from a class. So let me create a new class so we can understand. Let's say we have a class called the class library. Now, the library, let's say our library should have a name. Let's make it final. Let's say our library should have a list of books. Let's say the books are just strings, a list of books. And now you see it's coming at me, the compiler is coming at me that it needs a constructor. We need to initialize it because
it's non-nullable.
Yeah, it is non-nullable. So if we had used null here, it still won't allow us because we need a constructor to initialize this property. If we had said is equal to, let's say, it's a string, let's say it's just an empty string. Here, there will be no issue. But we don't want to initialize because it's a class. It's when we instantiate a new object from this library class that we want to give it a name. So what we can do here is not create a constructor like we said in the last class. We need to create a constructor. Now we can go through the stress of creating the constructor ourselves. But because we installed all this extension, you can just control and click on any of these properties. Control and click. Sorry, control and period. Control and the period. Then you see generate constructor. You can click generate constructor. So it's going to generate the constructor for us. If you can remember, this is the syntactic sugar I mentioned in the last class. The other way of the other way of constructing these properties is like this. Name, and then here we can use our initializer list to say this dot name should be the name that the user passed. That the calling object passed. And you can see this to be the calling object. Then you can instantiate you can call the constructor like this. But then you can see this too much of typing. I just use the syntactic sugar. Let's Control Z and go back. This is the same thing as what I've just said. So now we have a constructor. We are calling the constructor. We have a class library. Now, what I didn't mention last class when I introduced you to classes, these fields, they have their own implicit getters and setters. Like they have their own implicit in another OOP language like C++, for example. if you want to access these fields in another, if you instantiate the object with this library class and you want to access these properties, you need to create getters for them. This is how you create getters. You see, string, it should be the, it should return as the property. If you want to get name, you say string get, and then you give it a name. You can't call it name here because you know we obviously have the property called name. So let's just say, let's give it double E. And we can use normal functions like this, right? But then it's just easy to just use arrow functions like I taught you in the functions class. So use arrow function. Say string get name.
So the name is double E or double BS. Is it what to us?
The reason is because we cannot give it the same name. You know, we already have an identifier here, name. So we cannot give it the same name.
Okay.
You see why. You see why soon when I instantiate the new library. You see why. So now we are returning. So let's say in the void main now. In the void main, we want to create a new library. Let's say let's use final my library is equals to, now we are creating a new library class, right? A new library object, I mean. Now I want to give it the name. Let's say the name is our library. Okay. And now you know it's expecting list of books, right? Let's see, books. Remember, a list. This is a list literal. Use this bracket. Let's say the first book inside this load of the range, comma. Second book is Harry Potter. Okay. Say third book is of a yellow. That's it. All right, now we are creating a new library. We've given it a name, we've given it some books in the library. So we can, if we can get this name here. The reason why I said that the programming language has an implicit getter method. Normal, you know, if you want to print the name of the library, you can say my library dot name, right? This is implicitly, this is an implicit
Yes.
get the name of this library class, to get the name of this object we have instantiated. So, like they said, behind the hood, right? Behind the hood, every property in that has an implicit getter. That's why we can use this dot notation here to access the name of this object that we have just created. That's why we can use this dot to access the name. In something like C++, we would have done something like this to get name to access this name. So alternatively, you can print the name with this getter that we have specified here. You see, this getter is returning, you see, is returning this name. Here you can see. It's returning this name, the property. The name property of the library. That's why we are using name with double E here to return the name. We cannot say name here because we already have a name, an identifier called name. We cannot use the same name again. That's why. So you get. So that's why I'm using name here. Now, if we print these two print statements, it should give us the same thing. Let me put that one. Let us
Underscore and
sorry, it's inside the OOP folder. I keep forgetting. So we have to hold on, let it finish. Let's clear some. So is, we have to put the OOP slash, because it's inside the OP folder, don't forget. So you see, it's printing the same thing. It's printing our library. Because this one is using the implicit getter that the Dart programming language has given us for free. And this one is the getter that we specified explicitly. This one, this name with double E. That's specifying the getter here. So they are doing the same thing. So in other programming language, other OOP languages like C++, if you create a new property, you have to create a getter method for it. If you want to have access to it, if you want to have access, the read access to that property in another file, you have to create a getter method for it. But in that, we have an implicit getter for us for free. So we don't need to create a getter for every property we have. So that's for getter. So getter is even useful in other scenarios in OOP, in that. Let's say we have, because I've not mentioned this before, we can encapsulate a field in a class. So let's say we have to encapsulate, that means the meaning of encapsulation here is just to make some of these properties, make them private. So we are making it private to this class or to this library, I see. We are making them private. To make it private, we use underscore. We use the underscore to make the field private. You can use underscore here. We are making it private. Now here we need to put underscore. We need to put underscore. And now we can just leave this one as name, and it's returning the underscore name. Oh, I'm sorry. I made a mistake. Main parameters start. All right, I don't think we can use underscore. You can instantiate a field in a constructor with a private variable. I think we can do that. So what we can do here, can instantiate.
So your voice is kind of low.
Hello?
Okay, it's better now.
Yeah, I don't know if I can get on that here. This episode. Well, can you hear me clearly now? Because of the recording. I don't want the recording.
Yeah,
Right.
it's better now.
If you're having any problem with the audio, please let me know as soon as possible. For the people that want to watch the video later. All right. Hello.
Okay.
All right. So I don't want to.
Okay.
I don't want to debug this right now until we get to encapsulation and all that. So let's just continue with the getters and setters. So now we have an implicit getter for every field that we create in that. And then we can create our own getters too. You can see we are creating a getter that returns the property that we want to return. So that's for getter. And then we have setters too. You can see getter, a get method is to get a property from a class or from an object. The set property is to mutate. The set method is to mutate a property of an object. Let's create a setter here. To create a setter, we use the set keyword. You know, here one wanted to create a getter here. We use the get keyword. So to create a setter method, we use the set keyword. Set, let's call it set first book. Taking the string. Then should just make the first book. Just can see the method we are saying set first book. We want to, we are supplying a list of books here. Now we want to overwrite the first, that means the book at index 0, that is the first book. We want to overwrite, let's say we have a lot of links here. Now I want to override this first book with something else. And I want to say this dot books at 0. So you know this does book at 0 is referencing this book here, this book's property here. And it's referencing the first one, the first book here in the list. And I want to set it to be the new book that will supply the method when we call it. So we are setting this does book at 0 to be the new book we're supplying it. Something else I should mention. I don't think you can have multiple properties in a setter. You can see it's telling me setters must declare exactly one additional. I want to do that. We have to use parameter. It's not even allowing me to use parameter. Only one. Okay. I use only one parameter. We are setting the first book to be this. So to see if this is working. Let's see. Let's print my library books here. So this is when we have not mutated the list of books at all. So now here we want to call the setter method. You see my library dot set first book. And remember, you can name this anything. It's just the method identifier. You can name this anything. And try to say it's just for readability, to be able to read it. I say it doesn't matter. Or for readability, but we know we want to set the first book with this method. So my library dot set first book, it takes in exactly one positional parameter. So let's see, want to make the book calculate. Oh, to use the setter method, we don't use the parentheses, we use the equal to sign. Use the equal to sign instead of the parentheses. So the setter method is different from any other method that you use the parentheses to supply the parameter. If you are using the setter method, the set method, you use the equal to sign to assign the parameter. So this book will be assigned, this Dracula will be assigned to you. So now here we have mutated the first book in the book list. Now let's print library.books. So we want to check now if it has mutated it correctly. So you can see in the first print statement, it's printing out the book as it is here when it has not been mutated. This is the first print statement. You know, we have not mutated the books, the list of books at all here. So here we are using the setter method to set the first book in the book list. So we are setting it to Dracula. That's why you can see in the second print statement, it's printing Dracula rather than Lord of the Rings here. You can see Dracula Harry Potter just like this one. We only mutated the first one. We can even go on to, let's say, we want to mutate the second book instead. Now I should know. It's only going to mutate Harry Potter because we are setting these books at 1. And the index 1 here, this is Harry Potter. Harry Potter is at index 1. So we print, you can see Lord of the Rings. Harry Potter is changing Harry Potter to Dracula because we specified here that we want to mutate the book at index 1. So now that should be all for setters and getters. We will be using this get and set method when we get to Flutter. Just keep them. Let's go to the first pillar of object-oriented programming. You know, last class I told you that we'll be entering the 4 pillars today. So what we can do now, let's create a new file inside this OP folder. To be sure that you're inside the OP folder, you can click, just click on it. Let's call it Mr. Toby, can you hear us now? You can hear us. Mr. Alelepa, are you still there?
Yes, I'm still here.
You created a new inheritance style.
Inheritance.
So now this is the first pillar we want to talk about. So let me just say this. Inheritance. The point of inheritance is just to inherit properties and methods from a class. We call it a super class, or call it a super class. That is, or the base class. Yeah. If you want to create a new class to inherit properties and methods from a super class, that's why we use. That's why we have inheritance. Let me draw something because I want to bring out an analogy. You know, we have our parents. We have our parents. We are basically inheriting some genes from our parents. So our parents are our super class. They are our base class. Us right now, we are the derived class. So I think you are kind of getting the analogy. Our parents are the super class. We are the derived class. So we are extending our parents. So we are inheriting from our parents. Let's create let's just continue. So for instance, we have a class. We have a class vehicle. Let's say our class has a property, a string called locomotion. Basically to move, right? Now we can create and then class method called move. It's just going to print moving. Right. So right now this is our super class. So I've mentioned this before. Every class in that extends the object class. Every class in that automatically extends the object class. The object class is at the topmost of our class hierarchy. So if you keep drilling down to all class that you have, every class extends the object class. You can control click to see the object class. Control and click on the object. I can do that again. You have to be on that object that you typed. Control. You see this blue. It's going to change the color. You can click. You see the object class. So every class in that extends this object class. Let's go back. Even if we don't specify, you see, even if we don't specify, automatically every class extends an object class. So to know that every class extends an object class, in an object in the object class, we have this method called string. If you can remember, I said inheritance. Meaning of inheritance, we are inheriting the fields, the properties, and methods of a superclass. So this method, it's inside the object class. Yes. It's inside the object class. That's why we have access to it here. That's why we have access to this string method in our vehicle class. It's because we are extending the object class. So if you control click again, you know we are inside this object class. If you scroll down, you see all this operator and all that. So that means you have access to this operator in any class we create. You have access to this. You see this getter method. You have access to this hash code to get the hash code of the object. Well, you see, this is the toString method that we're using. So you see, this is where the toString method is specified. So we have access to all these methods, runtime and all that. So in your own spare time, you can just glance through this object class. So that's why we have access to this toString method. You can see this toString method is implemented inside our object class. So that's why we have access to this string method. So just keep that in mind. Every class automatically extends the object class. So let's continue. So we have a class vehicle, has a property, locomotion, then the constructor, and a method called move. So if we create a new instance of a vehicle, we can call move, right? Now let's say we have another class. We have another class car, and it's extending. Now we use this extends keyword to tell us that we are inheriting from a superclass. So we are saying car and class car extends vehicle. So now automatically, right? Automatically, every field and method from this vehicle class will be available to us in our car class. Let me copy it. Every properties or fields and methods in this vehicle class will be available to us in our car class because we are extending this vehicle class. That means we are inheriting the fields and the methods from the vehicle class. So now you see it's screaming at us because if we're extending from this vehicle class, we are automatically instantiating, or we are automatically calling the constructor. Rather, we are calling the constructor. And now you can see the constructor. In the constructor, we are specifying that we have to provide this property. We have to provide this locomotion property. So now to call a constructor of a superclass, we use this keyword called super. Now this is even giving us an intelligence here. We can control and then period and this rest line, this car class, this car identifier. You can control and period. You see, create a constructor to call super the vehicle. You click on it. Now it's creating the constructor. Now it gives us this super. I think we are running out of time. So it gives us this super keyword. Now he's expecting us to provide this locomotion property. In the vehicle class, we are asking for, in the vehicle class, in the constructor, we're asking for a locomotion. A locomotion is of type string. So here, is a name parameter, right? I'm sorry, is a name parameter. So now we can just say locomotion, colon, and then we can give it our string. Let's say, let's just give it a random string. I don't have anything. Let's see. Okay, by land.
Okay, I want to say train before.
All right. Just say by land. No, remember it's a car. It's a car class, right? It's a car class. So I just want to give it a random string. The way a class locomotes is by land, right? So let's just give it by land. So it doesn't stop us from specifying our own fields. This is a class too. This car is a class too. Let's say the class's property, final string, should have a name, right? Should have, let's just say color. I can't think of anything else that the car has, like a simple something. So you can see that's a name, that's a color, right? Also, we have to specify in the constructor too. If we want to instantiate, if we want to initialize these properties. So you can control and click on the class and the distance on the car constructor too. And you see generate constructor, click on it. So it's giving us, a positional parameter. But remember, I said I don't really like positional parameters. Most times I use name parameters. So you can just put them inside a curly braces and then make them required. So now we're all good. You can see required, but we're all good. So now we are calling the superclass. Hey, remember when I said this colon here in the constructor, if you have a constructor, I'm putting this colon here. we are using the initializer list to initialize the fields. So in the initializer list that we can use the super that we can call the superclass. Okay, so we are instantiating the superclass with the constructor here using the super keyword with this initializer list. So now, anytime we create a new object from this car class, automatically we are instantiating the vehicle class too. So we are not only instantiating the car class, we are instantiating the vehicle class to test this theory. Let's say, you know, this is a constructor, right? Let's say in the constructor we want to print. Let's print vehicle constructor. I want to test this theory. Let's say in our void main, we want to create a new object, a new car class object. Let's say var. Okay, let's make it final. Final. What car can I pick? Hold on. Let's see Toyota. Equals to car, right? It's asking for a name. The name should be Toyota. Let's see, the color is red, right? So now, even without printing anything here, even without doing anything, you know, this is the main method, right? Here we are just instantiating a new object from the car class, right? But remember, I said if you are extending the car class is extending the vehicle class, right? And I said if you are extending a class, you're automatically calling the class's constructor. This is the vehicle class constructor. And the constructor we are printing vehicle constructor code. We want to test that theory. So we are in the inheritance library. You can see that's run. I forgot it again. You're inside the OOP folder. Sorry about that. OOP. You can see we are not printing anything here, but it's telling us vehicle constructor code. Now it's validating that theory that I just laid out. I said it's automatically calling the superclasses constructor. So that's why we are using the super keyword here to initialize any variable that the superclass or any field that the superclass is asking for. So here is the locomotion property is required. So that's why here we are using the super keyword to provide the locomotion property to the superclass. You can say super keyword to provide the locomotion property to the superclass. So our car class is extending the vehicle class. So you know, let's say, okay, hold on, let's take away this. This is just to test the theory, right? You can see our vehicle has its own method. Move. That doesn't stop our own, you know, we are extending here. Doesn't stop our car class from having its own method. I hope you can see here me. And if you want me to come back. Hello.
I'm with you.
All right. So it can have its own method. Let's see for its drive. It's just going to print drive. All right. It's just going to print drive. So our vehicle class has its own method. Our car class has its own method. So remember, I said we have access to the properties. So this is a property and the method of a superclass. So that means in this car class we can reference locomotion, and we can also reference this move method. So you see, this move method is inside this vehicle class, right? but we can still say car, sorry, Toyota. Toyota is the object, right? Yeah, I say Toyota dot move. You see, you can call the move method on Toyota because it's extending the vehicle class. I don't want to confuse you. Just follow it carefully. The move method specified is implemented in the vehicle class, but it's because we are extending or we are inheriting from the vehicle class. That means we have access to the properties and the method. So that's why we can call the move method on this car class. You can get. So now we are calling Toyota.move. And still call Toyota.drive. Let's run it. You can see Toyota.move says moving, Toyota.drive says driving. Because the move here, the move method here is printing moving, and the drive method here is printing driving. I hope you can get that. Hopefully. All right, so let's continue. Let's create another method. Sorry, another class. Let's see. Something else I want to mention. Okay, let me create another class first. Let's see. Class ship extends vehicle. We can even extend car instead of vehicle here. You can see extends car, right? But it's asking us because we have to give the superclass. It's the superclass, cars does have blah blah. Forget about that right now. But you can see you can extend the car class and it won't give us any issue. You can, and as well, we can extend the vehicle class. But the issue here is we cannot extend two classes at once. It won't allow us. We can never extend two classes at once. We can only extend at most one class. You can only inherit from one class. And you might have a question in your mind, like, since automatically any class we create is extending the object class, right? You know, I said it's extending the object class, right? So
You added new.
So you see, I said we can only extend a class at once. If we created a new class ship, right? And you know, I said since we can only extend one object at once, I said that, and automatically every class extends the object class. So how come we can extend vehicle here? You know, it should be like we are extending vehicle and we are extending the object class. And I said you can only extend one class at a time. So the way that come over this bottleneck, the way they did it is that when you are extending another class, like right here, we are extending the vehicle class. Now this extend keyword and the vehicle overrides the default object class. So now this car class doesn't extend the object class anymore. Like explicitly here, it extends the vehicle class. And now the vehicle class itself is extending the object class. So automatically, the car class is extending the vehicle class and extending object class automatically because the vehicle class is extending the object class. So by default, the car class is extending vehicle and objects. So it cannot extend any other class here. It cannot extend, yeah, we are saying ship extend object and extend vehicle. It's not possible. It's not possible. You can only extend one class at a time. So yeah, let's say we're extending the vehicle class, right? At least in a way, ship to is a vehicle, right? So let's say our ship should have a string name. Should have, let's say, weight. Let's create the constructor. Now you know it's has to give the superclass, to give the locomotion property in the superclass. You can control and click on the ship and this ship constructor control plane. See, add super constructor, blah blah. He's asking us because it's a name parameter, information, colon. Let's see, what should we give here? Let's see, by C. Remember, the car is by land, right? The car is by sea. So you can see this thing. So it can have its own methods. See, void sail. And see, sail. You can see. So both the car class and the ship class are extending the vehicle class. They are inheriting from the vehicle class. You can see. So in the ship class too, if we instantiate a new object from the ship class, we have access to the move method because it's inheriting the move method from the vehicle class, and it also has access to the locomotion property. So you can see here, here we printed Toyota.move, Toyota.drive. Can even print Toyota.locomotion. Let's see what you see. You see, Toyota.locomotion is saying by land. Why? Because you see here in the car class that we're extending vehicle, we call the super constructor, right? We call super, and we are specifying that the locomotion should be by land. Is this one? We specified the locomotion to be by land. So when the constructor of the vehicle class is called, and I said when you instantiate a new car class, automatically it's going to call the constructor of the vehicle class because it's extending the vehicle. When the vehicle constructor is called, we are specifying the string locomotion here should be the string locomotion we specified, what we call the super class. So that's why when we said when we created a new object from the car class here, right? Created a new object from the class. And I said we have access to the locomotion property, and then we specify that it should be this string by land. That's why when we printed Toyota.locomotion, it's printing by land. So alternatively, if we create, hold on, let's say we create a ship. Let's call the ship Titanic. We have a name Titanic. We have weight. I don't know the weight. Let's just give it a random weight. It's a double, right? Let's say 1,000. So, right. So now we can print Titanic locomotion. Let's see. It's printing by C because here we said we call the super class, right? And we provided the locomotion to be by C. That's why it's printing by C. You can call Titanic dot move. You can call Titanic dot sail. But we cannot call Titanic dot drive. Why? Because the drive method is inside the car class, and we are not extending car class. We are not extending car class, we are extending the vehicle class. That's why we have access to the move method, right? And we have access to the sail method because the sail method is part of the ship class. So we cannot call Titanic dot drive. Let's try it. Let's try Titanic dot drive. See, it's not even giving us the prompt to see. The method drive isn't defined for the type ship. It's clear enough. It's telling us that we don't have the drive method in the ship class. So that's kind of the introduction to inheritance. You can see you have a superclass. That's the superclass, and then you can extend from the superclass. You can create a class that extends the superclass. If the class extends the superclass, automatically it's going to have access to the fields, to the properties and the methods of the superclass. And also you can only extend or inherit from one class at once. So if you create a new class, you can only extend one class at once. And also all class in that extends the object class. So the object class is at the top of the class hierarchy. So if you keep drilling through every class, you are going to end up at the object class, because the object class is at the top of the class hierarchy. So all types in that inherits or extends the object class. You get now. So now, because this class also extends the object class by default, because the vehicle class, I said it can extend to two classes at once. It's extending the vehicle class, which is also extending the object class. So we have access to the toString method here. When we get to polymorphism, you see why we are using override here. So just know we have access. We can get rid of the override to one get. It's just to tell other programmers that this method is actually overriding another method. You have access to the toString method. This is calling the super.toString. It's calling the super class. It's calling the toString method and the super class. So this one is just to print the properties of this class. So this is what we use the toString method for. You know, if sometimes once in a while, if you print a class, it's telling you instance of something instead of it to print the properties, right? So here, if you want to print the properties, you can just print it here. You can print it in the toString method. So you can format it the way you want. See, we are using $sign for string interpolation. Don't forget, anything at the right of the $sign is going to be evaluated. We are using string interpolation. So if we print, for instance, here without the toString method, let's see. Without the toString method, if we just go ahead to print Titanic, we go ahead to print Titanic, see what it will tell us. Hold on, wait for it to. So you can see it's telling us instance of ship, and it's right. Titanic is an instance of the ship, right? If we print Toyota, we print ordinary Toyota. Let's see. Say instance of ship, instance of car. So Titanic is an instance of the car. Toyota is an instance of the ship. But because here in the ship class, we are overriding the string method here. So this is how we want. Whenever we print Titanic, this is what we want to print out. We don't want to say instance. So if we print out an object that is instantiated from the ship class, this is what we want to be printed out, not instance of blah blah blah. So here, let's keep it like this. So you see the difference. So now we print Titanic and Toyota now. You see, Titanic is telling us name is Titanic, weight is 1000, because this is how we specify that we wanted to be formatted. It's going to print the properties. We want to print properties of the class that is static. We use this toString method. You can see here we did not specify the toString method in the car class. That's why it's still saying instance of the car. You can still go ahead and call it. You just type should bring this out. Let's just get rid of this one. See, should be. Now format this anyhow. So now, when we print this out, we can see it's giving us what we wanted. Toyota, name Toyota color red, name Titanic 1000. So hopefully you can see. So that's all about inheritance. So the next thing we will talk about now is polymorphism. I think that shouldn't take too much of time. So make sure you're inside the OOP folder. Let's name it polymorphism. Start. Right. I briefly talked about importing of libraries in the last class.
Yeah, last class.
So I said every file you create here, we call them libraries, right? Every file you create, we call them, every dat file you create, we call them libraries. So I want to import the inheritance library. Let's import the inheritance library. Let's say import. If you see, even if you type I, it's going to prompt you. I just click import inheritance like that. Don't worry about this blue screen because we are not using the inheritance library yet. So now here we can hold on. I class self driving extends the car class. We can extend the car class here because as you can see, the car class is implemented in the inheritance, but that's far, right? That's why we can use the car class. Let's comment this out so you can see. You see there's an error. Classes can only extend other classes because car is not a class right now. It's not specified inside its library. But we are importing it from this inheritance of that. So it's giving us this error because we are not calling the super yet. So we can call it, but before we do that, let's just give it some fields or properties. Let's say final string name as usual. Let's say final string color. And then let's just create the constructor. Generate generate constructor. It needs the super, it needs to call the super constructor. I say super. Remember, we need to specify because in the car class is asking in the constructor of the car class. You can see. Where is it? Constructor of the car class. In the constructor, we said that the name and the color is required. So this is what we need to specify. This is what we need to provide when we call car constructor. So that's why here we cannot say locomote. Casey. You cannot say locomotion like in the car class because here the super class or the super class of the car class is the vehicle class. It's asking for locomotion. That's why we are using locomotion here in the super class. But once we are extending the car class, you see in the car class the constructor is asking for name and color. That's why here we have to specify the name. Now I want to say the name should be this name here. The name should be the name that we give to it when we instantiate a new object on self-driving. Oh, I forgot something. When you are creating a class, you start from the capital. You're asking for color, right? Say the color is color. So now it should be all right. It should be good to go. Don't forget, the name here is for the super class. The name here is a property of the super class. And then this second name here is this one. Okay, we can even use, I think we can use this. Okay, we can use this. Okay, I use this. So the name here, you can even call this, you can call this one anything, as long as it's matching this property. Okay. For instance, if we say names, then here we have to specify it. Yes. You have to specify the name, you have to specify the color. I think it's giving me one. Oh, We are calling self-driving constructor. Remember, this one is capital in upper case. This one should be the same name. Should be the same identifier class. So now we have the constructor, we have our attributes, we are calling the super class because we are extending the car class. So there will be no. So I want to test something for it. So let's create a new let's call it Tesla. Because it's a self-driving car, right? Let's call it Tesla. Let's call this, let's see, this is white. Open. We're calling this session. All right. Let's say in the super class, let's call it the constructor of the super class. Let's print something. What's it called? Print this. Let's print color. Remember, I said whenever we are inheriting from a class, we automatically call it the constructor. So in the constructor, we want to print the name and the color. Let's print this. So it's not inheritance. It's polymorphism like that. It's printing Tesla and white, even without printing it here. It's printing Tesla and white because that's what we specified. We specified that name, yeah, the name, the color should be the name. We are calling in the super class, the constructor are printing it. Yes, that's why we have super class. Let's show you something. All right, let's get to this. So, what polymorphism means? I think about polymorphism, just to morph something, to change something, to mutate something. And most times we are talking about methods of classes. So we want to mutate the method from an inherited class. So that's why we have polymorphism. This override keyword, when we say string. So this to string is specified in the object class, right? And now in this derived class, we want to call our own toString method, but we don't want to use the toString method from the object class. We want our own implementation of the toString method. That's why we are using this override annotation. This override to tell other Dart developers that this toString method is actually specified in the superclass, but we are specifying our own implementation. We are not using that the superclasses implementation. We want to use our own implementation. We want to morph the implementation to our own taste. That's why we're using this override implementation here to tell other developers. So, in the superclass, in this car class, we have, let me see, where is it? This car class, we have a method called drive, right? You can see we have a method called drive. We can override that class, that method here. You can see, right? You see, if you just type GRI, you see it's giving us an IntelliSense here. If you click on it, it's already giving us that override application. So now we can have our easy implement drive. We can have our own implementation of the drive method here. So in the super class, which is that class, we're saying driver, right? In our own self-driving class, we are overriding drive method. Instead of printing driving, I want to say AI driving off. All right. So we have the drive method here, the derived class, and we have the drive method in the super class. So let's print Tesla with drive first, so you can see. Print Tesla with drive, it says AI driving off because here Is it? Here we are overriding the drive method of the car class. If you had not specified the drive method here, if you can think about it, if you call Tesla.drive, it's going to call the drive method of the car class. Listen, I'm going to print this. So it's going to call this method. So let's print. This is saying driving because it's calling the method of the superclass. This Tesla.drive is calling the method of the superclass. But once we want to morph it, want to change it to our own implementation of drive. No Teslas, they are self-driving, right? Most Tesla, I don't know if all of them, but they are self-driving. So yeah, we want to use our own implementation of the drive method. That's why we are annotating it with this at override keyword here. So to tell other that developers that in the superclass, we actually have a drive method, but we are morphing it to our own taste here. So now if we call Tesla.drive, it's going to call this drive method here. Well, if we don't have the drive method here, it's going to call the drive method of the superclass. I hope you are getting it. Hello? Hello?
I'm here. I'm here.
All right.
I'm here.
Okay. I hope you are getting it.
Yes.
So I can still print Tesla dots. So here, okay, we are not overriding the toString method. The toString method is from the object class, right? toString method is from the object class, the top class in the hierarchy. That's the object class. So we are not overwriting it here. I'm commenting it out. So if we just print this line, we print Tesla. It's going to say instance of. Hold on. Oh, in the car class, I forgot it. In the car class, you can see we are overriding the toString method in the car class. So that's why it's printing Tesla color this thing here. If we had commented this one too out, so I've said instance of self-driving chassis. It's because we are inheriting from this car class what we call self-driving. We extend the car class. And the toString too, the car class has already been overridden. Has already been overridden and has been supplied the name and color and all that. So here we don't need to even use the toString. We don't need to override the toString method again. But we can still override it if you want. So it's not going to call the toString from the car class anymore. It's going to call the toString from here. So let's see here. Let's just see toString called from self-driving, right?
Self-driving is capital.
Hello?
Self-driving is capital D.
Yeah.
Okay.
String called from self-driving. And say name. Say color. Let's put it. It's just for printing sake. You don't actually do that. This is says to string called from self-driving. It's printing it out like this. You see, it's calling this to string here. If you had not specified this one, to have called this to string from the car class, right? You see, it's calling it to string from the car class. And if you had not specified to string in the car class too, it's going to call it to string from the object class. And the to string from the object class is just going to tell us instance of self-driving. So you can see. Let's call the to string from the object class. Now let's go back here. So now we are overriding the to string method. So that means we are using our own implementation to implement to string. We are using our own implementation of the to string method here. So we can format it anyhow we like. That's just all about polymorphism. It's just to morph the methods from the superclass to our own taste. It's just to change the implementation to how we want it. That's just all about polymorphism. We've talked about we have talked about two pillars now: inheritance, polymorphism. Now we still have abstraction and then encapsulation. Kind of getting tired. Let's see if we can tackle them. So now let's go to abstraction. Abstract classes. So let's create a new abstract. Click on the open folder to show. Let's call it abstraction dot. So the reasoning behind abstraction is just like you are specifying a contract. That is even kind of too much. Just think about we are specifying a contract, like you are specifying some fields and methods. You are not going to give those methods or fields their own implementation yet. You are just specifying that we have these fields and method right now. Then you can have a class. You can have separate classes that implement this abstract class. That means you are going to write the implementation details of this abstract class. Let me give you an example. To create an abstract class, let's see abstract. This I'm running out of an example to use. Let's say Dua, right? Abstract class Dua. Now you can see void do something. Do something is a method. The abstract class. We are not going to give it a body. You know, we have a method, you have the method body. This is the block, right? But you are not going to give it a body. You're just telling it that you have this method. So now you can have another class. Let's see. Effective. Now we use this implement keyword. You know, when we're talking about inheritance, we're using the extend keyword to inherit from a superclass. Now we are using this implement keyword to implement the methods or fields from this class. It's implement Dua. So now I see it's telling us missing concrete implementation of Dua to do something. Hold on. Let's have another method. Let's say do something else. Now it's not going to have the method body. So it's not going to have the method body. So we can control and period here on this effective Dua. Control and period. So to tell us create two missing overrides. This is telling us override. Remember, we use this override when we're talking about when we're tackling the polymorphism. So this is also kind of in a way we are using polymorphism here. But this is also an abstraction. We are abstracting the implementation details of these methods. So we have these methods here. And then we are having the implementation details here in this effective Dua. So we can have so many classes. Let's see class. I don't have any examples. Let's see. Truth. I'm running out of identifiers. Implement Dua. So we must implement, we must write the implementation details of all the methods. Even if we have 20, we have to implement all the methods. So if I control and click, you see, we have to implement all the methods. So now the implementation details, let's just print do something. Let's see, do something else. So now, something else you need to know, you can't instantiate an abstract class. Let's write our code. You cannot go on and see final, let's see, apps. Because you cannot see Dua, then instantiate it. It's not possible. Can you see? Abstract classes can't be instantiated. You can only instantiate the normal class. So here we can instantiate effective Dua. You can see. So ABEST, ABST is a new object on the effective Dua. And now go on and say ABST dots something. Say ABST dots something else. I know you will not, you can, you will not appreciate why we have abstract classes right now. Because it all only has to do with writing clean code, clean and then nice code for other developers to be able to read. So when you've written so many code, you see why we need abstract classes. Right now, you won't see the usefulness right now. So if you have, I'm thinking of examples for you to use abstract classes. Let's say you have methods that you want other developers to know that when you are using this method, this abstract class, you need to implement all the fields and methods. So if you are calling an abstract class, if you're implementing an abstract class, you have to write the implementation details of all the methods. So you cannot go ahead here and say you don't want to implement, they do something else. It won't allow us. Missing concrete implementation of do something else, because it's telling us here. So we have to implement all the methods. We have to provide at override because we are morphing the methods. We already have the method here. I want to write our own implementation detail. That's why we are using at override here. You can do it without annotation to work, to still work, but to tell other developers we are overriding an existing method. You can just put the at override. So we are overriding an existing method, and we are writing the implementation detail here. That's why we have abstract classes. So I think for now that should be all about abstract classes. I don't think we'll be using it in this bootcamp because it just has to do with a clean code and all that. So I don't think it's just to let you know about the 4 pillars of OOP. You go to other object-oriented programming languages, you still see their own implementations of all these pillars of OOP, which is inheritance, abstraction, polymorphism, and then encapsulation. So I'm thinking of an example on how to tackle encapsulation. So, let's go under encapsulation. Let's start. After this one, just give me a minute.
Okay.
Let's see. Let's see, we have a class.
Okay.
Class called question. It has a string body, right? It says that's final bool answer. The answer should be either true or false.
Yeah.
Let's create a constructor. So now, let's see, we have another class called quiz. It's not extending it, it's just a class. This class is just to model our quiz. This was kind of the project I prepared for this session. But we'll be adding, I think, maybe in the next class or so, because we are lagging behind. I don't think we'll be using this again. In the next class, I want us to just go into Flutter directly. But now, let's just use this example. So we have a class called quiz. We have a list of questions. Let's call it questions. So it has to be a list of questions. First question. The body is, let's see. Let me think of some questions. Okay, I wrote some questions. Okay. Laugh at my question. Do you watch football?
Yeah.
So that's the first question. All right. The third question. This one should be false. Should never go. Should never even go again. All right. You can see, yeah, we have a list of questions. Now, okay, we are still inside this encapsulation. Let's create another form called encapsulation underscore demo. That's that. Now, here we have our void main. We say, okay, we want to import this file, this encapsulation file. You know, normally we have said import, right? Import encapsulation. You can do that. Or to save us all that time, you can just do this. I reference, I just type quiz. If you type quiz, it's going to automatically import it for you. See, it's importing this. Let me try again. So you have line 1, line 2, like just control and okay. Don't control and you just say quiz, and it brings out this IntelliSense. Just tap on the quiz to import it for you automatically. So now let's see. Final, we are creating a new instance. Final quiz. Should be quiz, right? Now we have access to these questions here. I say quiz dot questions. Sorry. Let's print it. I think it's going to print instance and all that. Let's see. That's wrong. Encapsulation
Calculation.
starts to be demo, because it's this demo that we are running the main.dat that we're creating this new instance, this new object.
Yeah.
All right, so let's run it. Hold on. Oh, I keep forgetting inside the OOP folder. Sorry.
Okay, folder.
So saying instance of question, instance of question, instance. So we have three instances, right? Because here we have 3 instances. So to just print out our question, we can override the toString method. So you see why the toString method is handy. Let's see. Let's see. Body. Right? The answer should be so. Now whenever we print encapsulation demo.dat, let me try this up so you can see. Okay, let me run it. Not cut off. And it's telling us because you see, because it's a list, we have this list, and we have the first one, body is the message, but answer is true. Second one, answer is true. Third one, you can see we are printing it out now. So now we have access to the questions, right? We have access to the questions. We can even we can go on and mutate the question. You can see quiz at question, sorry, at 0 should now be sorry, quiz at question at 0 dots, let's say dots answer. Hold on. Let's see. Okay, because it's a final. Where is it? It's a final. Let's go and see the final anymore. So here you see, you can say quiz.questions. Follow this. This quiz is the quiz object that we have just instantiated. Quiz.question, we are referencing the question. See, we have this dot question. No, I said it that every method, every field or properties in the class, every field or properties in the class has an implicit getter method. So you know this is a property, right? This is a field or property, anyone. It has an implicit getter. So you can use the dot annotation for it. So you can say quiz.questions. Where is it here? Rather than saying quiz.question. And quiz.question is a list. You know, it's a list here. So now we are referencing, we want to access the third question. So that's why we are saying, oh, it's not at 3, at 2. Because if we say at 3, see, this is at 0, at 1, and at 2. So you get. So we don't have at 3. If we go on and say at 3, it's going to give us an error saying something about range and all that. Let's try it again. But let's not print here. So let's try. It's supposed to give us an error. So you can see Fernando exception, range error. You can see invalid value, not inclusive, blah blah blah. So what it's just saying is that we don't have a question at 3. That means we don't have a 4th question. That's just what it's trying to say. So I just wanted to change the answer of the 3rd question. That's the question at number 2. So you can see here, this is the 3rd question. This is the questions at index 2, or it should be at number 3. So this is it. So we are changing this answer to be true. Here, quiz.questions at 2.answer should be true. So, but we don't want this kind of thing to happen. Okay, this is the issue. We don't ever want this kind of thing to happen. It's this file. We don't want to be able to change an answer just like that. See, we are changing the answer. For instance, let's print. Okay, before we change it here, let's print question quiz questions at 2 dot answer. So let's print it after we have mutated it. So here we are printing it before we mutated the answer. Here we have mutated the answer. And here we want to print it after mutation. So now if we run, you see here is giving us false, which is the right answer, because here you see right, and now we are mutating it now to say true. That's why it's giving us true. So we should not be able to do that in this file. And here comes in encapsulation. So we don't want another library to have either read or write access. We want to restrain. We want to give it a constraint. We don't want another library to have read or write access to this field, to this classes field. So what we can do is we'll make it private. We want to encapsulate this property in this class. We want to make this property private. So to make it private, you know, in C++ or other programming languages, most especially C++, we use this keyword, private, we say private and all that. Well, that has made it easy. In that, we just use underscore. So if we use underscore, that means we have made this property private. Now it's private to this library. So you can only have access to this question in this library. You cannot have access to this question in another library. So you can see here, you can see it's giving us the getter questions, blah, blah, blah. It's not blah, blah, blah. It's just giving us this error because we don't have access to questions. Okay, you know, it is underscore questions now. It's not questions anymore. Now, if we use underscore now, it's still giving us an error. We don't have access to underscore because quiz is now a private field because we have encapsulated the property in this file. Now, to make this property readable, we want to give a read access to this property. We have an arc around it. We can say list. That's why we have getters, right? Getters and setters. You can say get, and now we can say questions. You know, I talked about getters and setters when we started this session today. So you can say get.
Yeah.
You can say get sessions. Now we are returning. You know, when I talked about functions, I said you can also use arrow functions, right? So you can use this arrow function and see underscore questions. So now we're only using this getter method to get the questions. So we are returning these questions here. You can see list of questions. So we are using this getter method to get the questions. So now here, now we can reference, okay, sorry, it's questions, not questions. This is a list of questions, right? Now in the encapsulation demo, we don't have any issue again. So you can see quiz.questions. Let's move this finally. You can see quiz.questions at 2.answer. But here we cannot set it. We cannot set the answer again because we only have access to the to reading the property through the get method. So we are only getting the questions. We are not setting right now. We are not setting. Now to set, can now say set, let's say set answer, right? Change an answer. And then let's say can receive a boolean. Let's just give it a short name. And say once that questions at, oh, hold on. Let's give it, I think we need an index. Because We want to know which answer to change, which question at which index to take. So instead of getting the hold on, bear with me. Instead of having the let's receive the index. It's index. You can see the question at that index dot answer. Remember, if something is final, you can't change it. So we have to remove the final because we want to change it. Now, the answer should be inverse of the answer. So what we are doing here, we are saying, we want to set the answer, we want to change the answer. We are saying the question at that index, any index we provide using the setter method, any index we provide, that's the questions at that index. So if we provided index at 0, so this index will take the 0. If we provided index at 1, so this will be 1. So we are saying questions at that index, let's answer. So let's say we said 0, so this is 0, index at 0. So this question, let's answer. So now we are now changing, this is true, right? We want to change it to be false. We are saying, remember when I said, when I taught you about all this if statement and all that, and relational operators, I said, whenever you negate something with this exclamation mark, if you are negating something, if it was true before, if you use this exclamation mark before it, it's going to change it to false. And if it was false before, it's going to change it to true. So here, this answer is going to change to true. This one is going to change to false. This one is going to change to false. So that's what we are doing here. We want to set the answer to be the inverse of the original answer. So you can follow the analogy. We want to set this answer, any index we provide, we want to set the answer to be the inverse. So if it was true before, we want to set it to be false. So here, you can now see we want to call quiz.set answer. So if you say quiz.set answer is going to take an index, let's say at index 3, or sorry, at index 2. So it's exactly the same thing as what we had before. But at this point, now we can now explicitly say that we want to set something. We cannot set it by mistake anymore because we are encapsulating the field here. So now, the only way you can change a value here is to use the setter. That means you are calling the setter explicitly that wants to set something. So now we can now say quiz.set answer, and we are giving the index. Let's say the index is 2. So now, here we said quiz.questions at answer at 2. Now, if we print it here, it should give us true, right? But now we are setting it, we are changing the answer here. Here, the answer should change to false. So let's try to print it. You can see. Sorry, at 2, it's printing false, and then we are negating it, it's changing to true. Sorry, at 2 here, this is the index 2. The answer is false, and then we are changing it with the quiz.set answer. Now it is true. So that's just all about encapsulation. It's just to encapsulate a field in a class so that other class cannot have read or write access to it. If you have, other library, not a class. Because if you have another class here, let's see, class, random, let's just see random. You can still have access to, I don't think so. Oh, you can't have access to the variable or to the property if it's a private property. You can't have access to it in other class, not only a library. So that's even the better constraint. You don't have access to it in another class. You only have access to it in that class Or if you have a getter method, like here, we have a getter method here. Hold on. I'm thinking of an example here. Sorry. Let's see. Right now, Q goes to is say quiz dot see q dot questions. So I was even right the initial time. Friends must have a method body because I'll write the initial time. So you have access to the questions in this library. Even if you create a new class, you have access to the questions. The only problem is when you take that class away from that library and you bring it. So you don't have access to it anymore. You only have access to the getter. So you don't have access to the private variable or the private property. I mean, inside this class, it's only inside this library that I can reference that private property. But once you are out of the library, you are inside another library. You don't have access to the private property anymore. So that's why we use getters. This is where getters come in handy. You can have only read access to it. You can have read access to that object, but we don't have write access. Only way we can have write access is using a setter. So that's why we have getters and setters. It's just for when we are using encapsulation and want to reference the properties. So that's why we have encapsulation. So we cannot now go inside another library and go and be setting the properties again, because we have restricted read and write access using that underscore to make that property private. So that's why we have encapsulation. So if you are still confused about this, I can go back. Tell me from where you are confused and let me go back. Or is it clear enough?
Yeah, for now I think it's clear. So I just have to go back to check the video.
All right. So I think in the next class, we are supposed to create a mini project today. But I think this should be enough, I guess, because the mini project is just like a build up to the project we are going to build to be building in Flutter, because it's kind of the same thing. But this one is just a command line application, just like the previous one we built. It's just going to run in our terminal, but it's just like a build up to the final project. One of the projects we'll be building in Flutter. But don't worry, I think we just build it in Flutter right away. So next class, we are going to start Flutter. So just be prepared, be ready for that. All right. I think you are using Android, right? Are you using Android?
Yes.
All right, no problem. So you are going to be using your phone to run your Flutter application. So your Flutter application is going to be running on your phone. So from next class, I think the next class should be more exciting, because that's why we're in this bootcamp. We're going to start writing Flutter applications. So thank you for joining the class.